Hi everyone, Elon Musk 24 Hours here. Today we're tackling one of the most controversial aspects of SpaceX's Starship program, one that's raising eyebrows across the entire aerospace industry. Standing here at SpaceX's facility, the massive Starship prototype looms overhead. But something crucial is missing. Something that every NASA human-rated spacecraft since Mercury has included. A launch abort system. That's right, just like the space shuttle before it, Starship won't have any mechanical escape system for its crew. The stakes couldn't be higher. When the Space Shuttle Challenger broke apart in 1986, the lack of an abort system meant there was no escape for its crew. Now, decades later, SpaceX is making the same choice for Starship. But are they repeating a fatal mistake, or have they found a better way? I've spent months analyzing flight data, studying accident reports, and examining every human spaceflight abort scenario in history. The answers I found challenge everything we thought we knew about spacecraft safety. Today on Elon Musk 24 Hours, we'll break down exactly why SpaceX made this controversial decision, what it means for crew safety, and whether this could actually be the future of human spaceflight. Let's dive right in. The morning sun glints off Starship's stainless steel hull as I stand here at Starbase. There's something haunting about this moment, something that takes me back to another morning decades ago when 7 brave souls boarded a spacecraft that, like this one, had no escape system. That morning became one of the darkest chapters in spaceflight history, the Challenger disaster. Today, as Starship reaches toward the sky, we face the same fundamental question. Can a spacecraft truly be safe without an abort system? The answer lies deeper than you might think, and it challenges everything we thought we knew about spacecraft safety. The Space Shuttle taught us bitter lessons about overconfidence. NASA claimed it would be as reliable as an airliner, with a chance of catastrophic failure less than 1 in 100,000. Reality proved far harsher. 2 disasters in 135 flights. But here's what many people miss. The shuttle's problems went far beyond its lack of an abort system. I've spent months digging through the data, and what I found changed my perspective entirely. The shuttle's fatal flaws were baked into its very design. The orbiter hung precariously off the side of its fuel tank, exposed to deadly debris strikes. Its thermal protection system was so fragile that a single piece of foam could punch through it. And those solid rocket boosters, once ignited, they couldn't be stopped. Even if the shuttle had an abort system, these fundamental design flaws would have made it dangerous. Starship takes a radically different approach. Standing here, looking up at its towering form, you can see the first major difference. The crew compartment sits safely at the top, protected from falling debris. But the real innovation lies deeper in decisions that might seem counterintuitive at first. Take the engines. Starship's Super Heavy booster will have 33 Raptor engines, a number that might sound alarming, but this is where SpaceX's experience with the Falcon 9 becomes crucial. Their Merlin engines have achieved something remarkable. 99.88% reliability over more than 800 flights. That's better than the Space Shuttle's main engines ever achieved. And unlike the shuttle, Starship can lose multiple engines and still complete its mission safely. But here's the most surprising thing I discovered. Launch abort systems aren't the safety silver bullet we've been led to believe. In the entire history of human spaceflight, mechanical abort systems have only saved crews twice. Once during a pad fire in 1983, and again during a booster separation failure in 2018. What they don't tell you is that abort systems have also caused accidents. In 1966, a Soyuz abort system accidentally activated on the pad, causing an explosion that killed a ground crew member. The complex reality is that every abort system adds its own risks. You're essentially strapping additional rockets, with their own potential failure modes, directly to your crew compartment. Recent testing of both SpaceX's Crew Dragon and Boeing's Starliner abort systems revealed dangerous flaws that could have been catastrophic. What makes Starship truly revolutionary isn't the missing abort system. It's the entire approach to safety. SpaceX is pioneering something we've never seen before in spaceflight. The ability to test, fail, learn, and fly again rapidly. They're not just building a rocket, they're building a development process that can identify and eliminate failure modes before they ever risk a human life. This mirrors the evolution of aviation safety. Early passenger aircraft often carried parachutes. Today, that would seem absurd. What changed wasn't the addition of more safety systems. It was the fundamental reliability of the aircraft themselves, proven through millions of flights. SpaceX plans to fly Starship hundreds of times before putting people on board. Each flight will reveal potential weaknesses and drive improvements in a way that's never been possible with traditional expendable rockets. But we have to acknowledge the challenges ahead. SpaceX's track record with pressure vessels, the tanks themselves, has been mixed. They've had several high-profile failures, from the CRS-7 mission explosion to the dramatic rupture of an early Starship prototype. These incidents remind us that even seemingly simple systems can hide complex failure modes. The difference now is that SpaceX can afford to fail during testing. Unlike the Space Shuttle, which had to work perfectly from its very first crewed flight, Starship can iterate and improve through failure. Each setback becomes a stepping stone toward greater reliability. The data tells us something remarkable. Over the last 30 years, only one launch out of roughly 180 would have benefited from an abort system. That's about 0.5% of flights. Yet the Space Shuttle, designed to be so safe it didn't need an abort system, failed catastrophically at 3 times that rate. Standing here at Starbase, watching the teams prepare for another test, I can't help but feel we're witnessing a fundamental shift in spacecraft safety. Instead of adding layers of emergency systems, SpaceX is focusing on making the primary systems so reliable that backups become unnecessary. It's a bold strategy, but one that could finally open the door to large-scale space travel. The ghost of Challenger will always remind us what's at stake. But perhaps its most important lesson isn't that we need more abort systems. It's that we need to fundamentally rethink how we approach spacecraft safety. For early flights, especially with NASA astronauts, Starship might need to adapt and include additional safety measures. But for humanity's long-term journey to the stars, the path to true safety lies in improving reliability through frequent flights and rapid iteration. Looking up at Starship's gleaming hull one last time, I'm struck by a profound realization. We're not just building a bigger rocket, we're pioneering a new philosophy of space safety, one that could finally fulfill the promise that the Space Shuttle made but couldn't keep, making space travel truly routine, reliable, and accessible to humanity at large. The data paints a clear picture. While abort systems have saved lives, they're not the only path to spacecraft safety. Starship's approach, focusing on fundamental reliability through rapid testing and iteration, could revolutionize how we think about space safety. But this evolution will take time, testing, and a willingness to learn from every success and failure along the way. Nine years ago, a tweet echoed through the space community. Jeff Bezos had just landed his suborbital New Shepard rocket and proudly welcomed Elon Musk to the club. There was just one small detail he overlooked. SpaceX had already been landing rockets for years. Fast forward to today, and the tables have turned dramatically. Now, as SpaceX celebrates its nearly 400th successful launch, Blue Origin stands at a pivotal moment. Their massive New Glenn rocket, after years of development, has finally completed its crucial hot fire test. The space industry watched in anticipation as the behemoth stood tall at Launch Complex 36 in Cape Canaveral, its 7-meter frame casting long shadows across the Florida coast. For Jeff Bezos, who recently broke his silence about the project, this milestone carries special weight. Under new CEO Dave Limp's leadership, Blue Origin has transformed from what critics called a slow-moving R&D company into an organization ready to compete in the orbital launch market. The FAA has granted their launch license, the static fire test succeeded, and now it's Elon's turn to welcome Blue Origin to a very different club. Hi everyone, welcome to Elon Musk 24 Hours. Today we're taking you behind the scenes of this historic moment in the commercial space race, exploring what it means for both companies and examining whether Blue Origin can truly challenge SpaceX's dominance in the orbital launch market. Let's dive right in. The journey of Blue Origin's New Glenn rocket tells a story of ambition, delays, and redemption. Since 2013, this massive launch vehicle has existed primarily in blueprints and promises, while SpaceX's Falcon 9 rockets have lit up the skies with increasing regularity. The space community watched, sometimes with skepticism, as year after year passed without New Glenn taking flight. Behind closed doors at Blue Origin's facilities, engineers wrestled with the complexities of building a rocket that could challenge SpaceX's dominance. December 2022 marked a turning point. Dave Limp stepped into the role of CEO, bringing fresh energy to a company that had become synonymous with careful, perhaps too careful, development. The culture began to shift. The methodical research and development approach that had defined Blue Origin gave way to a more decisive stance. Engineers who had spent years perfecting systems were finally given the green light to move forward. Then came November 21st, 2023, a day that silenced many critics. The massive New Glenn rocket, standing nearly as tall as the Statue of Liberty, rose vertical at Launch Complex 36. The Florida sunrise painted its metallic surface in shades of gold and orange, a sight that brought tears to the eyes of team members who had dedicated years of their lives to this moment. But the real test was yet to come. On December 27, the calm of Cape Canaveral was shattered by the thunderous roar of BE-4 engines during the first fully integrated static fire test. The ground trembled as 3.85 million pounds of thrust poured from the rocket's 7 engines, sending a massive plume of exhaust across the launch pad. Hours earlier, the FAA had granted the launch license, a vote of confidence in Blue Origin's safety protocols and engineering. Jarrett Jones, Senior Vice President for New Glenn, couldn't contain his pride. Today's success proves that our rigorous approach to testing, combined with our incredible tooling and design engineering, is working as intended, he announced to his team. The words carried special weight coming from a man who had weathered years of skepticism about whether New Glenn would ever see the launch pad. The rocket's specifications tell their own story of ambition. Its massive 7-meter diameter payload fairing dwarfs the industry-standard 5-meter fairings, opening new possibilities for satellite deployment. The first stage is designed for 25 flights, a testament to Blue Origin's commitment to reusability and cost reduction. With the capability to lift 45 tons to low Earth orbit and 13 tons to geostationary transfer orbit, New Glenn positions itself as a versatile workhorse for the commercial space industry. But looming on the horizon is SpaceX's Starship, a behemoth that threatens to redefine what's possible in space launch. Standing 120 meters tall with a 9-meter diameter, Starship isn't just bigger, it's a different class of vehicle altogether. Its 16 million pounds of thrust make New Glenn's impressive specifications seem modest by comparison. Yet Blue Origin isn't necessarily competing with Starship. They're targeting different markets, different missions, different futures. The stakes couldn't be higher. Blue Origin has secured contracts with Project Kuiper, Amazon's satellite internet constellation, UTAT, and a spot in the Pentagon's $5.6 billion National Security Space Launch Phase 3 program. These aren't just business opportunities. They're chances to prove that Blue Origin can deliver on its promises, that the years of careful development weren't in vain. Jeff Bezos' vision extends beyond these immediate goals. In a recent statement that raised eyebrows across the industry, he predicted that Blue Origin would eventually surpass Amazon's $2.3 trillion market cap. It's an audacious claim, but Bezos has a history of turning seemingly impossible dreams into reality. The upcoming launch, scheduled for early 2025, carries more than just a test payload. It carries the hopes of thousands of engineers, technicians, and dreamers who believe in a future where multiple companies compete to access space. The payload itself, a prototype spacecraft named Blue Ring, symbolizes Blue Origin's broader ambitions. Designed to facilitate the movement of other spacecraft in Earth orbit, it represents a future where space operations are routine, reliable, and commercially viable. The space community has witnessed the transformation. Blue Origin has evolved from a company known primarily for suborbital tourism flights with New Shepard to one poised to challenge the status quo in orbital launch services. The shift hasn't been easy or quick, but it carries a powerful message. In the space industry, persistence and careful engineering can eventually catch up to early success. As we stand on the brink of New Glenn's historic first launch, the space industry finds itself at a fascinating crossroads. Blue Origin's journey from that infamous "Welcome to the Club" tweet to today's orbital-class rocket represents more than just technical achievement. It's a testament